you so much, Daniel. That is
Very
so
nice.
awesome. So those of you who just joined us, hopefully you saw the schedule. Either you're joining us by Zoom or YouTube Live. That's Daniel Holbach, who is a community manager on our developer experience team here at Weaveworks. We're really lucky to have him, and that's just fun. We just thought we'd add these bits to our show. We've got lots of talent in our team, and why not share it? Um, we still have to create a DJ name for Daniel. He talked about how he had this bookmark DJ name in the past, didn't want to share. I'm not sure if we hear your mic. Um,
Sorry.
oh yeah.
I think it's fine. It's fine. We're good.
We're gonna crowdsource this. By the end of this series, we'll have a crowd recommended DJ name. So yes, definitely share that in any of the chats. We'll let him choose though. We won't impose any DJ names on him. But great. Well, thank you so much. Thanks for everybody who's joining by Zoom and YouTube Live. If you've seen any of our posts, we have a meetup page called the Weave Online User Group. You might have found it there on Twitter, not sure. But we are going to run a GitOps Days event next month. But with COVID and such, we've had to learn a variety of platforms. So we thought, well, why don't we test out and learn about these platforms with the community. So we're putting these out there. Stacy here, who at least on my screen is on the top right, I think. She's been learning up a lot about, today we're using OBS. I think some of you who may know about it may be familiar, but she's a quick learner and she's really ramped up really quickly. So that worked out quite nicely. And we'll be trying other platforms as well. So if anybody in the community can give us guidance, we definitely welcome it. Give us feedback. But we're actually really excited that this is working today because we were feverishly testing this out yesterday a couple times, and at that point, at least we knew what wasn't working, and now Stacy, in her brilliance, has made it work. So we're very excited to have this, and we're really excited to have you here, and we're excited to have our team. So I've introduced Daniel, who if you don't already know him, he's been a community manager in the Kubernetes space and with us here at Weaveworks. Stacy's also community manager, and we're based here in California. And you probably also know Lee Capilli, who we're very excited has been in our team for a while now too, and hails from Denver, Colorado. If you know Lee, you know that Lee's been involved in the Kubernetes community for a while, even before joining Weaveworks. He's been maintaining projects such as Ignite that Lucas Karlstrom, who's also with us at Weaveworks, created. Both Daniel and Lee are very involved with SIGs, working groups, and with giving back to the community in ways that require lots of patience and long-term vision. And we're really glad to have him. And we're also, yeah, Lee's always hacking on stuff and contributing in different ways. And one of the ways that he's helping is with the GitOps Hands-On. So I'll share the link one more time. If you've just joined today's show, we'll have a variety of things, like I said, music, different stuff. And Stacy, actually, if you could post it on YouTube Live, I did miss it on that side. Stefan Pradhan on our team, who's also a developer experience advocate and the creator Flagger, created this hands-on so that for people who maybe have read about GitOps or have seen talks about it, you know, it's definitely a different thing from being able to read about it and actually feeling like you have been able to implement it in some way. So we are very lucky to have this hands-on and to share it with you. And if you haven't seen it before, normally we kind of start with an intro talk that Lee will give today that kind of gives you an overview of you know, what's going on under the hood, how you can kind of understand the value and the magic that's going on, so that if you do it, when you do it on your own, you know, you don't miss those bits. But today what we're going to do is we're going to do that, and we're also going to spend the last, I've bracketed about 90 minutes, where we're going to do an experiment and see if we can walk you through it. So if people get stuck, and it'll happen, please you know, call out and ask for help, and we'll do our best to see if we can get you through that. Otherwise, if you look at the page, we have a Slack channel dedicated to this hands-on, where at any point in time you can come and ask us for help if you get stuck. And there is also a link to share your information. There's a T-shirt involved with this. When we do these as in-person events, obviously this is an in-person, so we can't give you a T-shirt. But if any time in the future we are at an event and we can do an in-person event again, then we will show up with them. And so please, yeah, please fill it out and let us know who you are, and that way we can also follow up to make sure that if there's any additional help that you need, you can get it. So with that, I will hand it over to Lee, who, oh yeah, that's the shirt. We have the Weave Get Up shirt. And actually, before I hand it over to Lee, yes, I'll do a requisite just overview. If you've never heard of us before, our company is called Weaveworks, which I have in the background. We're a startup based in London, San Francisco, New York, Denver, and Berlin, with distributed teams as well. So in fact, Lee is over in Colorado, Denver, Daniel's in Berlin, Stacy and I in San Francisco, and Stefan and we have another guy, Chanwit, on our team, are distributed in Romania and in Thailand. They do a lot of great stuff. Um, if you've heard of us before, you've probably heard of us because we have a lot of great open source projects. As I mentioned, Flagger is one of them. Flux is now in the CNCF, and Lee will definitely be including that in the conversation about GitOps. And that's kind of the technology that got us to this term of GitOps and the concept, which hopefully you'll stick around for our event next month. We'll really be revealing how our new CTO is seeing GitOps in the next evolution. So kind of started with this CI/CD concept of GitOps with Flux, but now we're taking it to various other layers and various other ways that we're seeing develop. So we also have others, WeaveNet, Cortex, which builds upon Prometheus. There's many, many more. We have lots of stuff. If you go to our Weaveworks GitHub page, you will see our various open source projects. And we also have products. So I'll do a quick mention. We have Weave Cloud, which is a SaaS product that helps you manage, monitor, and do automated deployments for your Kubernetes clusters. I think there's a variety of bits that really help. It also has like Flux as a service, but it also has Prometheus as a service. So if you are looking to do monitoring with Prometheus and you don't want to install it and you don't want to maintain it, Weave Cloud may be a good option for you. We've been running Weave Cloud on Kubernetes on AWS for over 4 years now. So we actually have experience running Kubernetes in production. And so with that, a lot of people asked us for help in that area. So we have productized the Kubernetes distribution layer that we created for our Weave Cloud product. And now we've come out with that called Weave Kubernetes Platform. And so since there are many, obviously, distributions and platforms, in our case, because of GitOps, we're making a very GitOps aware enterprise platform. So in some ways, you'll be able to get a taste of GitOps using open source today with Lee and us. And if you get that taste and you think, well, I'd love that on an enterprise level, and I'd love that with things like Teams and more access privileges that you can control, that is WKP, the platform that we've created. If you want to check us out, our website is weave.works. And so you can check us out. So with that, I'll hand it over to Lee. And if you're also on YouTube, I'll have to mention, please subscribe, and you'll be able to see our future events as well. And so with that, I'll hand it over.
Thanks, Temo. Yeah. Hopefully everything is sounding good still. As Temo mentioned, I just wanted to get into a little bit of an introduction. Some folks were already asking like, hey, I'm joining from here and here, and I would appreciate some description about the benefits and the reasons why you would do GitOps. So just going to share my screen. Let's pop down to a couple slides here. One of our peers here at Weave, his name's Paul Curtis, he put together these slides, which I think are a very succinct explanation of what and why Kubernetes and what and why GitOps. And so there's, if you're in a really massive company, then there are some benefits here that you would want to consider. I don't think that these are exclusive to large companies, but they start to really surface at scale. We did a talk just last week about some of the more general and soft skill reasons why Kubernetes and GitOps make sense together. But really, like if you're choosing Kubernetes as a platform, you're looking for the flexibility of all the integrations of the systems that go with it. And then you're going to want the benefits of the auditability, the compliance that come from the declarative descriptions of the API. And so when you're working with Kubernetes, right, like you don't just like have these mutating statements, you work in a declarative way. It says like, I would like the system to look like this. And because you have a description of how the entire system is supposed to look, it makes it easier to understand from a security perspective and from an auditing perspective whether or not something was compliant. And then, yeah, because of that, you can get rid of a bunch of systems that usually put glue and friction in place to prevent bad changes from happening. Since now you can work more effectively, it increases developer productivity. You move faster, you can deploy faster, and then you can imagine that the world is just easier for people, right? If you decide to use Kubernetes. So some bad reasons to pick Kubernetes, but there are plenty of good reasons. And then getting into what and why GitOps. So we have this declarative system, but the system itself might not be something that is around forever, right? And so, like, say you started with a cluster on these machines and now you're upgrading hardware. It is much more difficult to transition the life cycle of that cluster into new hardware than it might be to, say, stand up a new one, right? And so you immediately hit this need where you need an abstraction or an interface that's kind of outside of the particular boundary that a single Kubernetes cluster gives you. You might also run into a need where you want to run multiple Kubernetes clusters. Say you're a small startup and you have a client in Europe and also in California, right? And those clients, use your product and are struggling with latency. So you decide to spin up a second version of the stack in Europe. And so when you hit the multi-cluster use case, you again need this layer that's beyond just the boundary of Kubernetes. And we in the DevOps world have used systems that give us continuous integration and deployment. So what's different about GitOps, right? So in that same layer of CI and CD, what makes something GitOps? And the main idea here is that the Git repository that you're working with should be containing state that is primarily declarative, right? And then also ideally minimal. And I'll get to that a little. But basically, once you have these declarative systems, you want to drive them in a declarative way because you can use kubectl run or kubectl expose, right? But those imperative constructs, those sugary commands that are given to you by kubectl in order to have you feel that succinct imperative workflow are not going to provide you the same kinds of benefits that the declarative system's really tooled and built to provide. And so if you can change the way that you work, right, so that you're no longer saying add one thing, right, or open or close this down, right, but rather describe what should be existing in a state of compute or state of networking, then you move that into the Git repo and you can automate the process around it. And then you'll always know from a version standpoint how things are supposed to look. So 1, the system is declarative. 2, the canonical version and store that we use is Git. Git is pretty much the lingua franca of the development world. It doesn't mean that if you are using Subversion or something like that, that it's not GitOps, but this is just trendy, I guess. And then as approved changes are committed to the system, right? So as they get into the Git repository, they should be automatically applied, right? This is a general guideline. If you make a commit and you need to do something else in order for that change to be applied and to be automatically converged and reconciled, regardless of what time it is, then the change was not approved yet, right? So if I change a manifest declaration, make the commit to the repository, and then somebody actually has to go and click a button in order to deploy that change. But then it's at that point that the change is approved, right? But then where you would see the difference here from a continuous deployment workflow is that those workflows are often event-based and driven from outside of the system. And point number 4 here is that really, as Weaveworks, an authority on GitOps, what we see as a mature GitOps practice is that you run these software agents inside of the system itself. And those systems are actually what's responsible for ensuring that everything is converged, and that if something is out of whack, that they fire an alert on it. So if you look at CI, right, we come from a pretty mature land of software development lifecycle, but our operations life cycles are lacking a bit. And I see GitOps as this step towards more mature operational life cycles for the infrastructure that's necessary to run our businesses. So you look at CI and you see this loop, right, where somebody's in their code editor, they're building their code, everything's kind of looking good, so they push it, and then now we've got some testing workflow, and that's CI, right? And these solutions are really well supported by a wide ecosystem of tools. Like, everyone's very familiar with this kind of workflow. If you hire a dev, you can be pretty sure that if they've been around the block, they're familiar with CI. And then you get into the DevOps world, right? And a lot of folks take the CI process and throw deployment in there. And this is not bad, but I would say that we can take steps beyond this kind of event-driven lifecycle, just shimming deploy scripts into the CI system. How can we do better, right? And so when we talk about GitOps, I love this picture, this concept of the immutability firewall, right? Which means that now we've got these declarative converging systems on the right-hand side, right? And so we have CI on the left. We're producing artifacts. The product of a CI system is that there are validated immutable artifacts in some versioned artifact storage, right? So you went from your versioned code to your versioned artifacts, and they have been validated in some repeatable manner, usually on an event-based loop, because development is iterative. Okay? But now we want to operationalize those artifacts, right? And so the difference is that CI solves an iterative process, right? But operations is a continuous process. And so when you add Kubernetes being a declaratively managed systems, and then you put a version, a source control system around it to version the declarations so that you always know what's happening, then you have these software agents that are running, such as Flux, inside of your cluster to make sure that that version is applied, then you get a really nice separation of concerns. And then Git is tying it all together, and you can get a whole view of what is supposed to happen in your software lifecycle and your operations and infrastructure lifecycle. So this reduces risks. It makes things much more transparent, provides the separations of concerns, as we mentioned. And you also get this freebie, which is that usually your Git provider gives you a lot of tools for declaring who has access to what, who can merge what, what's the policies behind creating release branch or tag and that kind of thing. So marries really nicely with existing software development lifecycle, and now makes your infrastructure operations much more mature. Cool. So pop that off. So that's the point of GitOps, and we actually get into that a little bit. But now let's segue to the hands-on. Did we have any questions just before we want to move on? Let's see. Cool. I'll move on. If you have questions, feel free to pop them in the chat. So what we want to go over today is the EKS GitOps Challenge. This is a self-led hands-on workshop that you can get running in your own AWS account, regardless of whether that's at your company or just your personal one. Particularly if you're concerned about cost, This workshop, in order to run it for like 2 days, probably cost you about $7. So if you were only doing it for just this afternoon, you wanted to play, I'd say it was probably less than $1 or $2 in US dollars. I know that we have people joining from all around the world, so I'm not sure what your currency conversion rate is, but it's pretty inexpensive to run. And we did validate in an isolated, brand new AWS account that if you followed the cleanup instructions, you will not have any reoccurring billing costs. So we did show our T-shirt. This is pretty cool. So, sorry, Tamo, did you want to say something?
No, sorry, I had a whatever 10-second delay because I was actually monitoring the YouTube signs that I heard you say that whether whether people had questions. So I just wanted to make sure I monitored, but looks like we're good.
Cool.
Yeah. So just we asked everybody, hopefully you're here to learn about GitOps. If there's any specific requests you have, please don't be shy and put them in either chat feed, and we'll include that. And hopefully the hands-on will also help cover that. So yes, thanks.
Nice. So for our hands-on workshop, this is providing infrastructure all the way up to the application layer. So true to GitOps, we'll be versioning and managing the infrastructure from a code perspective, and then declaring the workloads and all of the platform needs necessary to run the code that we want to deploy through the Git repo. And in order to get the infrastructure, you're going to need an AWS account, as well as some binary dependencies. And so there's a bunch of install instructions here. We do have some great resources at the beginning of this lab. So we just talked a bunch about why and how you could convince your team and your organization to do GitOps. There is a very succinct explanation here in the lab as well, if you want to share this lab with your team members, as well as how to discriminate between GitOps and some CI anti-patterns. And then the more interesting bit, which is what we'll work towards in this lab, is about progressive delivery. Now, progressive delivery is this developing industry term that kind of circumscribes deployment and traffic shaping techniques merged together. Right. So when you deploy your infrastructure, normally the way that your traffic is shaped is kind of roughly determined by your load balancer algorithm and the shape of your compute. When I say the shape of your compute, say you're doing a rolling update or a blue-green deployment, right? So in a blue-green deployment, you usually spin up all of your A instances and your B instances, right? Or your blue and your green one. So your blue instances are currently receiving traffic as the current version of your app. The green one is the next, right? And when you want to open the floodgates, then once your green application is up, all of the instances are ready to receive traffic. You just add them to the load balancer and you start shifting it over. Right? And because of that deployment model, normally the percentage of traffic that is being shaped towards the green deployment is roughly based on how many machines are available to receive that traffic at any particular time. So when we start to talk about traffic shaping, we can do things like weighted routing, right? Which says like, okay, for this period of time, I would like 5% of the traffic to go to the new instances, right? And then I want to monitor and see if there's any anomalies that we potentially could attribute, right, to the new code being deployed. You can also do things like say, hey, I just want to shift only Firefox users or only Android users, not the iOS users, right, to my new version of my mobile app backend, right? And if you'd like to do that kind of traffic shaping, then you need something that's very aware of the traffic. And most deployment and network systems are not at this point yet. And then even then, the integration points that let you do those kinds of things are often imperative, and you need to get creative about how to bolt on your own desired behavior. So what's exciting to me is that you heard Tamo mention Stefan Prodan earlier, and he built Flagger. Flagger is a progressive delivery operator, It's a controller that'll run on top of Kubernetes in a declarative way. You get all of the benefits of controllers running on Kubernetes, being that they are, it's very easy to describe that only one of them should exist inside of Kubernetes at any one time. And you can do that with a high probability. The state that is driven by controllers is stored in a consistent storage. Also, another thing that you get for free, Kubernetes is backed by etcd, which has consistent reads and writes. And then when you combine those two things together, and then you build a reconciliation loop, which is something that can be driven by a declarative state, and then you can implement a state machine using the consistent storage, then you have something that's highly available and guaranteed to recover pretty well. Guaranteed's the wrong word, but I mean, like, that's a very resilient system. And so this is a huge difference if you're trying to do progressive delivery versus running a bash script inside of a CI system, like based off of some commit, right? Or trying to run a cron job on a Linux machine, that's a little bit closer, right? But when you're using Kubernetes to schedule the operator itself, you have a bunch of benefits in terms of the resilience of your system. And when it comes to ensuring some declared state about the policy by which your traffic should be routed, I think that it's pretty important to make note of this, because you could build something on your own, or you could try to use somebody else's thing, but I'm going to be pretty confident that this is going to be less brittle. And so Flagger is really dope. You basically have this canary release object. It allows you to do canaries, A/B testing, and blue-green deployments, right? So regardless of the ways that you want to shift your traffic in relation to the deployment, it gets you away from how many pods are available to serve things, and now you can start to leverage your service mesh for real. And yeah, so you basically go through all the prereqs, you install the AWS CLI. This is a little Go tool right here that just makes it easier to connect to your Kubernetes cluster. It's a recommended install, technically not required. We are going to use GitHub, so I'm going to make a Git repo, and then you'll need an account there. EKS Cuddle. This is a really great tool that my good friend, ex-Weaver Ilya, what am I doing? EKS Cuddle IO. That's the website I want to go to. We have a great logo, super cute gophers everywhere. There's like more at the bottom. And basically, yeah, the EKS Cuddle is the official Amazon recommended CLI. It's an open source tool. So you can go to our Git repo and open up issues and check the roadmap. It's got a very open governance model. You can even contribute your own patches and that kind of thing. If you want to work on EKS Cuddle or have your own particular use case, feel free to fork it too. And yeah, we are able to distill down to one command what is a fairly complex setup just to be able to create a cluster in your default region. And if you want to do something more special, then EKS Cuddle has a great API. It's a declarative one. And so similar to Kubernetes API machinery, right, I can say, hey, inside of the EKS Cuddle API, this particular version, right, I have a cluster config that describes the way that I want a cluster to be created, right, and managed, upgraded, whatever. And then you just give it a name and a region. You can see that this is a metadata field similar to the Kubernetes API machinery. And then I provide a list of node groups. Right? And so this is a fairly minimal config, but you can see that I've extended beyond just a naive command, and I'm not just using flags. Inside of the node group here, you can see we have a YAML list. I have a default node group with the instance size. We've got a couple of those, and with some storage attached. And then we have this IAM section, which provides you with a lot of sugar for what you would normally need to do on your own. And here we can say that, hey, out of the nodes inside of the default node group, I would like them to have some policies that allow access to AppMesh, another API inside of AWS, as well as the X-Ray API, which is necessary for viewing AppMesh metrics. Right? So that's interesting. Well, AppMesh, Is that like an AWS product? And the answer is yep. It is a service mesh that's built on top of Envoy, and it has X-ray compatible API that exposes a bunch of red metrics, right? So that's rates, errors, and durations for the services that you deploy into App Mesh, right? Which is a service mesh that gives you traffic shaping and routing and waiting breaking capabilities. And so here we're able to then use the EKS Cuddle API to create a cluster that provides me a node group with the proper IAM policies necessary to administer and utilize and create a service mesh. And then you can see I ran this not that long ago. It took about 16 minutes. And it's powered by 2 CloudFormation stacks. And yeah, go check it out if you haven't checked out EKS Cuddle before. So that's where I'll stop for the intro portion of this. But yeah, just go ahead and get the remaining binaries, Flux Cuddle, and customize if you want to do. This is technically optional. You'll also need kubectl if you want to inspect the cluster, but you won't need it to write to the cluster or anything like that. And yeah, feel free to get the dependencies, follow along, and we'll do some progressive delivery a la GitOps and AWS infrastructure in just a bit.
Oh, thanks. Let's pause for any questions. So yeah, if anybody here is not signed up to actually do it in this moment, like I said, we'll take a brief break and then we'll actually dive into experimenting for the first time, doing this online and helping people walk through it. Yeah, does anybody have any questions in general about GitOps and the concept of progressive delivery and how you might be able to do it with Flagger? Has anybody here used any of these components before? I saw a couple people in the chat who've used Flux. Anybody here new to Flux and are curious about any of the kind of open source GitOps tools that are out there? And is anybody new to Flagger? I think I saw some people who use Flux but not Flagger yet. We'd love to hear from you because then that way we can tailor the next couple hours to make sure they help you out. And let me remind, so for people who are on Zoom and people who are on YouTube Live, in Zoom, if you're new to the platform, there should be a button to open the chat box. It's usually on the top left corner of your screen. If you don't see it, hitting escape gets you out of full screen mode, which could help you to get there. Okay, thanks. We have one person who said haven't used either. Yeah, I'd love to hear more. Do you use any tools today that do some type of GitOps and you're looking for something else, or you're new to the concept of GitOps and you're hoping to find out how these tools might be able to help? And while I'm waiting for your while I'm waiting for your answer, I'll see if there's anybody else on YouTube. Anybody on YouTube Live as well? Have you used one or either, or have you used other tools right now that perform sort of GitOps qualities? Okay, we have someone else looking to introduce GitOps in organizations. So yeah, in fact, some of the things that we're working on are, like if you want to go to a conference, often you get, there's like a sample letter you can bring to your manager that justifies the value of your going to the conference. So we've had quite a few people come and say like, okay, I've studied up on this, or maybe I've done the hands-on and I really think this is something that's great to bring to my organization. How can I get them started and get them excited about GitOps? So I've been kind of putting together this idea of like a discussion kit, like a GitOps discussion kit, or like a package of things that we'll put together where you might tell someone on the business end, or you might tell your team or help them get started. In fact, we've been at some companies where it just so happened that the day that we were there, someone was doing an internal workshop on Flux and getting their whole team on board and getting them comfortable with some of the concepts. So we're putting these together to hopefully help you, right? Like you're talking about, I'd like to introduce GitOps to my organization. So if you have any thoughts around that, like any like friction or any challenges, like please do let us know so that we think about that when we're putting together this kit. Anybody else? Anybody else in the place where either you yourself want to be convinced of whether GitOps is the way to go, or whether you feel like you'd like to bring that to your organization, but there might be you're concerned about certain resistances. Like one of the companies we talked to, like they talked about how there's it might be a really huge org with many different teams with different backgrounds and skill sets. So some of them might be really passionate about particular tools or ways of doing it that's not really GitOps. And we're not in the business of being in a battle about it, but if you want to have those discussions, we can help there. And then on the opposite end, we've had some people who just say, like, I need to even get my organization up and running on concepts around microservices. Like there's a much longer path for them to go to feel comfortable with even the concept of GitOps. And definitely, yeah, no judgment. Everybody has their different areas, but it's been really helpful to hear, like, yeah, what kind of materials can we provide to get people on their journey? Because people, especially with COVID and stuff, people have busy lives and other things. It's not like they all have tons of time to be studying up on things on the weekends or on their own time if they're not getting paid to do it. So we have a few others. Let's see, in this section. Someone has a question about something in the actual hands-on bits. Tell us more. And also, yeah, reminder, if you're posting in the chat, please post to everyone so that people can see your chats. I'm going to copy paste this for you here. So we have one person who shared this part of the hands-on, so I guess we can cover it when we go through the bits. One place, from a manager point of view, it might be difficult. At least some people have experienced that, so that's good to hear. Yeah, definitely, people have different perspectives or backgrounds that they come from, and it might be challenging if you're trying to convince them of the business value or software development velocity. Like those are the types of areas that we might have to think about. There's a question about SSH keys.
For the enable repo command?
Oh, okay, so that's what he's asking about.
Yeah, from what I recall, believe the after you run enable repo, the Flux key is printed to the screen, and then you just pop that into your settings. Excellent. We'll run through it in just a moment, but from my understanding, that's what I remember makes it work.
Okay, so cool. With that, if you have any other comments or questions, please put them in the chat. We'll take a 3-minute break if Daniel wants, is available, and then we'll dive into this. That'll give you some time to get your laptops and computers ready if you want. Kind of run through some of the instructions, and we'll walk through it step by step. I hope that works with you. But we'll give you a little moment to do that if anybody needs to grab a glass of water, get a bathroom break.
Maltratei, sim, maltratei demais. E machuquei, que meu coração que bate calado, 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 que bate, bate.
just toss that ham in the frying pan like Span. It's done when I come and slam. Damn, I feel like the son of Sam. Don't let me wreck ya, hectic automatic. Got me going like General Electric. And the lights are blinking. I'm thinking it's all over when I go out drinking. Oh, making my mind slow. That's why I don't with the big ball. Oh, bro, I got to maintain. Cause Kasabian is going insane. Insane in the membrane. Insane in the brain. Insane in the membrane. Crazy insane, got no brain. Insane in the membrane. Insane in the brain. Insane in the membrane. Crazy insane, got no brain. I'm a couple hours in time for the blubber blabber. To watch that Betty get fatter, fat boy on a diet. Don't try it, I jack your ass like a looter in a riot. Much too fat, like a sumo, slamming ass, leaving your face in the glass. You know I don't take gluto lightly. Punk is jealous cause you can't outfight me. I kick that style, wicked wild. Happy face, hope you never seen me smile. I rip that mainframe, I'll explain. Sergio is going insane. Insane in the membrane. Insane in the brain. Insane in the membrane. Crazy insane, got no brain. Insane in the membrane. Insane in the brain. Insane in the membrane. Crazy insane, got no brain. Louis Armstrong, play the trumpet, I hit that bong, I break it all song. 3, 2, I got to get my prop. Cops come and try to snatch my crop. These pigs wanna blow my house down to the underground, to the next town. They get mad when they come to raid my pad, and I'm out in the night, who's God? Guess I'm the pirate pilot of this ship. If I come with the ultraviolet dream, live on the headlight beam, and now to you believe in the unseen. Love will make your eyes strain. Kasabian is going insane. Insane in the brain.
Eu quero que você pense muito bem no que aconteceu a nós dois, no que aconteceu e depois então me diga se você acha que devemos prosseguir ou desistir do amor. Eu quero que você pense muito bem no que
I don't know if Danny can hear
aconteceu a
me.
nós dois, no que aconteceu
Sadly, we
e
have to
depois então me diga
wind down this awesome music.
se você acha que devemos prosseguir ou desistir do amor.
Thank you, Daniel. What is that last awesome song? Oh, he's got to get his earbuds on. Hey, Daniel, what's that awesome song?
Which one?
The last one, it sounded like maybe it was Portuguese.
Yes, it is called Fatnotronic and Inflagranti. That's the artist.
Okay.
Mediga.
Diga, yes.
Yes.
That's awesome. Well, thank you so much.
Yeah, no worries.
Yes. I hope you guys are enjoying it. Yes, you can obviously give us feedback, but we definitely enjoy listening to Daniel. It's always great to see different people's talents. So thanks again. If you just joined, we have gone through kind of an intro to this GitOps Hands-On that we'll be doing. So now we're going to dedicate the remainder of the time. We've kind of carved out a chunk of time. If you really like to go through this with us, and we have a couple of people who have gotten started and had a lot of questions, so that's great. So it's a bit of an experiment. We're both on Zoom and YouTube Live, but let's see what we can do. So we will, I guess we'll go walk through the steps by steps, and please don't be shy. Like, obviously this isn't really valuable if you're not able to finish. Again, there is a Slack channel that you can go to later if you feel like you fall behind, but we're going to do our best to see if at least, let's say, a goal of 50%. So at least if we could get you to, a 50% point, so that if there are any points where you get stuck, we can help you live and on the spot. We're going to try to do that. So why don't we get started? And I'll just note, Daniel, I know it's really late for you, and I know this is your day off. So I was expecting just a recording, and instead we got super awesome live music. So if you need to drop off, no problem. And it's really great to see you as always. So with that, I'll hand it over to Lee.
Hey, was just opening up a PR actually for that SSH Git remote bit. So great. Thanks for the feedback. And
was it mostly about just adding or changing some documentation around SSH?
Yep. Yeah.
Okay.
So just changing the way that that the clone is done.
Okay.
Yeah.
Cool.
And I think that was maybe the only bit here. And then yeah, we do provide a SSH Git URL already in the enable repo command. So
Okay.
it was just this bit right here.
Cool.
I'm not. Oh, am I not sharing my screen?
Oh yeah. Share your screen.
Yeah, I was like pointing at things and didn't make any sense. But yeah, I figured I would open up this docs PR since somebody was already running through the lab and then hit an error because I had put in some. I normally don't actually run that command because I use the hub command line tool. So hopefully that will fix things. That should build to the website pretty soon. And great. So where were we? If you haven't had a chance to take a look at the lab, you can read the intro and go through the prereqs, which will install the binary dependencies and guide you through account setup. But otherwise, you'd need to create a cluster in your account. So the two things that you would potentially change here would just be the name of the cluster and the region. So I changed my region to US East. Oh no, for this particular cluster, I'm using the exact same settings actually in my personal AWS account. And the next thing, so you make this cluster, you follow the EKS Cuddle API, you see it creates a node group in the cluster with IAM access for the app mesh service inside of AWS, which will provide you a managed service mesh to go along with your managed Kubernetes cluster. So you can describe that with this API, you hit create, and then everything is set up correctly and there's capacity in the zones of the region, and the region is supported by AWS for EKS, then you'll have a cluster in about 15, 16 minutes. Well, mine took 17, I guess. There we go. These are pretty beefy nodes. Again, cost to run this lab is probably $7 for 2 days, so less than $1 for just an afternoon. And yeah, you can see my cluster here is not very old at the moment. So I've been around for probably less than an hour now. I'm connected up to it just using kubectl for read-only access. And you can see we're running Amazon Linux with kernel 4.14 and recent version of Docker. Cool. So now that we're hooked up,
Sorry.
yeah, what's up?
Thought we'd just pause in case we want to walk people through the page. Do people need to download anything or get things started?
Yeah, the prereqs. We mentioned this in the earlier talk, but maybe you're just joining us now. Is go ahead and if you don't know what GitOps and progressive delivery are, then we've got some introductory content here that links to a few blog posts as well as provides some succinct descriptions. GitOps is this way of marrying Kubernetes, which is a declaratively managed system, with a version control system outside the cluster. Some key benefits of GitOps would be that when the cluster is not there anymore, you still have all of your declarative state, and it's actually versioned, which is extra sugar on top of Kubernetes. You get some major benefits from having versioned your changes to the declaration, in addition to the ability to collaborate on them in a way that's familiar to your teams. GitOps, I think the main reason, if you want to have like a main selling point, is that it is what will ensure that you can still run your business the same way in 4-10 years if you want. I find that people will migrate off of a platform or try to re-architect or build a new system. The main reason is because they're just not good at operating it anymore, or they don't even know how it's supposed to work or how it's built or deployed, or maybe the tools that were supposed to keep you building and deploying to those systems have now been, maybe they were brittle, in ways that are no longer usable.
And I'll just interrupt for 1 second. If anybody could tell us on the chat, like how many of you are planning to follow along and will need to still download some of these prerequisites and get them installed? That would really help us to know how many of you we are going to be helping here. Or if you have a preference to see. Okay, so we have someone who's following along. And where are you on this? Have you gotten all the prerequisites, or do you need a few minutes to at least get those started? And if so, we could definitely walk through some of the concepts. Anybody else? Okay, when you say you're good for now, you're just following along, or you're all set up? Okay, so you're just following along for now. Okay, creating a cluster and setting up the Git repo. Okay, excellent.
Yeah.
Someone's all set up. Excellent. Anybody else? Like I said, we'll at least try to get people to the 50% mark. So if you do need to at least get things downloaded and installed. Okay, then Craig's got some questions here, some errors. Anybody else joining on either Zoom or YouTube that is planning to go through this with us, and let us know where you are. So if we need to give you a little bit of time for the prerequisites, let us know. We definitely don't want to leave people behind. Okay, so why don't we check in with Samit here, creating the cluster and setting up the Git repo. So hopefully that can be our start state. And Lee.
Yeah, I am taking a look at this error message right here.
At least for me, parts of your screen are grayed out.
Oh,
you have some kind of protective. Yeah, now is that looking that way for you, Stacy? Like right now in Zoom, I'm seeing a gray screen, and yeah. So like,
I see. I think that's just a Zoom not showing things that people are not always supposed to see.
Okay, that's probably good. I'm not sure.
Yeah, because I can see what it looks like on the YouTube stream.
Yeah.
And that is peculiar. Yeah, it's basically just blocking out itself. So
yeah.
So this error is describing
so we can't see that.
Yeah.
Yeah.
So this error is describing an issue with EKS Cuddle not being able to see Helm operator running. And I will just put this into a code window. This now.
Is it possible in this view to make the font? Okay, great. Yeah.
So basically, I think it was Craig that ran this EKS Cuddle enable repo command. And then it says here that Helm operator is not ready yet. So you look inside of the cluster, Helm operator is ready and running. And so the error message specifically says could not find pod for selector. And then it says labels name in Flex Helm operator. So it seems like that's doing a label selector and inside of a particular, so this is inside of the Flux namespace. So I'm gonna give it a go. Maybe this is potentially something with a new version of EKS Cuddle, and I'm using the most recent version. So if that's the reason, I'll run into the same problem. Go to the lab. Just gonna make a Git repo really quick.
And actually, is that the same stage that you're at, Samit? Just want to check in to make sure you're. Let us know if you're moving along the hands-on and where you're potentially getting stuck.
Empty repo. Copy this. Let's go. Clone the repo. There we are. Urban Rotary Phone. Great repo names from GitHub. And all right.
Samit's still waiting for the cluster to be created.
Okay, cool. Shouldn't be too long. And then about 15 minutes from the start of your create cluster, on average, is what I've found. And then I'm just trying to see if it's potentially possible to reproduce this bug.
So Craig used EKS Cuddle 0.18.0-RC-0.
18.
1.8,
Seems
yeah.
a little bit newer than what I was expecting, because I am using the most recent stable binary release, which would be 17. I don't think we've done an 18 release yet.
This is RC.
Okay, yeah, it was a release candidate.
Yeah, I was asking one of the engineers on the EKS Cuddle team if there are any major concerns. I haven't heard anything yet. Samit is 0.10.2. Samit's wondering if he should upgrade from 10.2 or just.
The last time we validated
Yeah, it was
this
10.
lab, it was 14, I believe.
Oh, was it 14? Oh.
We have a particular version of EKS Cuddle that's recommended inside. Yeah, we recommend 0.14. This is because during KubeCon we patched some bits for 14 to support the ephemeral node groups. So I would recommend patching.
Okay. So is it easy to find 10.14 or I guess 10 or 0.14 or 0.17?
Yeah, we've got some installation instructions. Oh, actually, we removed the brew. Oh, no, yeah, that's correct. Okay, and then what was the repo name? It's right here, Urban Rotary Phone. Here we are. So we're cloned, and then now we'll just go ahead and run the enable repo command. So the intention of the enable repo command will enable the experimental features inside the repo. The intention of this command is to bootstrap the cluster with Flux and get it hooked up to the Git repository that's hosted by GitHub over the internet. So that'll work with a public or a private repo. And then right here, I am working in the same region and cluster name. So that name and region from your cluster config would match the enable repo command. just so you can select the proper cluster. And then these bits right here are just to configure Flux when it like adds tags to your repo or things like that. And then the git URL I just have templated with some environment variables. And I'll see if I can get a reproduction. Forwarding port, connection refused. So my Helm operator started successfully. That didn't fail for me. I'm not using the release candidate, but this should succeed very quickly for you if it is a pretty declarative command. I think you should be able to rerun this if you get the proper version of EKS Cuddle. Or please let me know if you're still having issues and you're not able to resolve it. But yeah, I'm not able to reproduce on my fresh EKS cluster using EKS Cuddle 17, which you can get from Brew or through the binary releases that we do on GitHub. Let me know.
We also have someone, Shell Sweet, over on YouTube Live, who's also following along. So I'll keep track.
Thanks for joining.
Yes.
Cool. Okay. Well, in the enable repo workflow, basically you hook it up to the cluster, and it goes in and it applies Flux and Helm operator for you to the cluster so that you can now start driving in a declarative way. And then it configures Flux inside of your EKS cluster to point to your Git repo. So this is, I think, one of the main differentiators about EKS Cuddle as a command line tool is it's not just doing infrastructure management for you from a systems perspective, but then it's hooking it up to you. It's hooking it up for you to Git, right? And this is a prerequisite, really, right, to GitOps, right? So getting Flux installed, you'll go immediately from day 0 from just having a cluster to step 4 of the GitOps maturity model that we were referencing in the first talk. So, which is having a software agent hooked up to a repository with a declarative system that can be driven by the state inside of a Git repository or inside of Git. So the last bit here, I think we should probably change the color of the logger. Because it's like a little bit difficult to see this, but it tells me, okay, well, I've enabled the repo and configured Flux and Helm operator for you. Everything is looking good and ready inside of the cluster. But now, could you please do something for me, right? Could you please configure your repo so that the following Flux SSH public key, right? So Flux's credentials have access to the repository. So I'm just going to copy this SSH key. You can also get this SSH key using fluxctl. So you should just configure it for the proper namespace. And then I'm just going to pop open into my Git repository, which I think I had open at some point. Yeah, here we go. And I'll pop into the settings. You could also do this with the API. And then I'm actually working on a controller right now that does this for you automatically if you just provide it a personal access token. But that you can, if you're curious about that at all, it's in GitHub controller. Christopher Hine, it's pull request 7. So feel free to take a look at that if you'd like. But yeah, I'm just going to add a deploy key. Paste in my SSH key from the enable repo command's output and name it. I'm going to allow write access here. It's not technically required, but you get some benefits like tagging and that kind of thing. There we go. So I've added the key. Soon enough, Flux should notice, and we'll be hooked up and ready for GitOps. Here's some things that I would do in order to check that that actually occurs. So I just have kubectl alias to k. It's just a nice shortcut for me personally. And I'm going to check the pods in the Flux namespace. And here we have Flux running. So then if I just k logs in the Flux namespace for, I think this is a deploy. Is it not? Ooh. Autocomplete's kind of slow right now. I guess I'll just copy and paste the pod name. And here we can see that the event loop was refreshed for it, and that should be good. So, and then the last bit is we did the enable repo command, so we should be able to pull. And oh yeah, we're in an empty repo still. And let's check up on any debugging. Samit, just by the way, if your cluster was created properly, you could probably just upgrade EKS Cuddle and use it on the same cluster. Yeah.
Wanted to check. So for the people following along, where are you now? Do you need a pause, or we can go back some steps if you want us to go through it again? Or are you still just in a waiting mode, getting those clusters up? And Craig, I'm curious whether you've moved forward with your same EKS Cuddle, if you decided to try out 0.17. And Shell Suite is also following along on YouTube Live, just checking to see if where you are. Are you around the same area that we're covering right now, or need a minute? Double check they're still there. I see you're here, Samit and Craig. Yeah, let us know. Definitely want to make sure that we're creating a valuable experience by letting you follow along. So just running ahead. While we're waiting, I was trying to remember when we did this ages ago, like from scratch. How long was the wait to just do the prerequisites?
Just the prerequisites from nothing on a very fresh machine is probably about 20 minutes.
20 minutes. Oh, good. So
it depends though, because you can run into all kinds of issues with package managers. I mean, like, I wouldn't be surprised if somebody had a snafu on their machine that like caused it to take them an hour to get the prerequisites done. That's just the kind of normal stuff that you have to suffer through as a developer.
Okay. Oh, Sam, thanks for letting us know. You said the prerequisites were actually pretty quick. So that's good. Nice. All right. Are we good to move forward? Would you like us to check in with you where you are? How's the upgrade to 0.17? Okay. Move ahead. Onward, he says. We shall move onward.
Cool. Okay. Well, now using the enable repo command, hopefully you've worked out any kinks that you had with the EKS Cuddle version and that kind of thing. So you have a cluster created with the API. It's synced up and it's ready. We even did some stuff ahead of time to enable IAM access for app mesh. And then we use the enable repo command with the fresh repo inside of GitHub and hooked it up to Flux and a Helm operator inside of the EKS cluster, right? So now if you see, like, I'm getting pods in all namespaces, we can see we've got the AWS node services that are running on the two nodes inside of the cluster. We have Core DNS and kubeproxy, which are standard add-ons that are typically installed inside of Kubernetes. We have the memcache that's backing the Flux that's running. And then in addition, we have the Helm operator from the Flux project, which allows you to use a custom resource to declaratively install a Helm chart. and release it, basically. So now we have this repository, right? I could start adding manifests to it. I could make commits, and I don't have to do any kinds of kubectl create or kubectl apply commands. I just commit them to the Git repo, and because Flux is hooked up to the Git repository, I don't have to access the cluster directly. One thing I will make sure is that my Flux forward namespace is set, and I'm just gonna, if you ever need to debug whether or not the Flux control loop is operating properly, what you can do is run fluxctl sync. This will do a port forward to the Flux API on localhost inside that pod. So it's a relatively secure manner of ensuring that the control loop has been applied to a particular commit inside of the repo. And yeah, you can see that it's hooked up to the proper repository as well. This can be a quick way for you to determine which repository a particular FluxD inside of a Kubernetes cluster is pointing at, which can get a bit confusing once you start having lots of namespaces and that kind of thing. So this is a good little tip there. And then I will be using the sync command after pushing to the repository, because in the enable repo command, we do not set up a webhook at this time. The webhook would allow you to get a faster feedback from the repository. The default control loop sync for Flux is every 5 minutes. So what we'll do is, now that we've enabled the repo, we have an empty repo, but what we really want is a bunch of infrastructure in order to support our service mesh needs for running our web application, right? And what we can do is use the enable profile command. So eksctl enable profile is another bit on top of just getting Flux set up. So now what you can do is have these repo templates that are published, right? And so we have the app mesh profile that can be used. Pick a particular revision, point it to a cluster, and this will bootstrap our Git repository so that you can get some infrastructure ready to use. So you go from something that's like just completely empty to something that's very useful all of a sudden. And you can see how you could make your own profiles and extend these and fork them so that you could build your own platform. Okay. So this idea of profile is super powerful. And I'm just going to check to make sure that these variables are set. We'll just grep for gh user and repo. Oops. Yeah, cool. So name. There we go. There we are. So here it is creating a temporary directory to mutate my repository. It's adding a bunch of base manifests into it. It's pushing it to my repo. And then now I can see that I'm out of date. So I will pull my repository in order to fetch the changes that the enable repo command just pushed to my public remote. So now you can see that if I were to, say, open up my code editor inside of this directory, my repository now has a commit with an app mesh system, a kube system, and a demo namespace, as well as licenses and a README to explain how this is working, a link to the workshop itself. And then the Flux namespace here, you can now see that the Flux that was in the repository in the enable repo or the Flux that was installed into Kubernetes during the enable repo command has now been added to my profile. Right. So if I wanted to, say, move to a different repository, I could come into the Flux deployment and I could change the way that it's configured. Right. So I could say no longer, use a different memcache service, right? Or change my SSH keys, point to a completely different repository or branch altogether. Right. I could point this to a dev branch or a production branch instead. And I can manage that repository change from the Git repo that it's currently pointed to. Here, there's an important flag that's been enabled inside of our Flux config, which is for manifest generation to be true. This is useful if you want to do things like create dynamic customized patches before your repos are applied to the cluster. Right? So Flux will go ahead and expand your customize for you. And yeah, that repo is up, and we can just make sure that FluxCTL is, or that Flux is synced. And we can see it already is. So if I look at my Git log, here was my initial Flux config, and then now we have the app mesh quick start, which this commit is from the profile repository.
Did you see Craig's questions?
Let's go ahead and take a look. Downgraded, now I get this error. Find a local clone, and then I'll go ahead and copy this into the code editor so everyone can read it.
It's true. I forget that. Sorry. I forget that the chat in Zoom is not shown on YouTube Live. So I don't know how to share that.
Copy this. So Craig says I downgraded to EKS Cuddle 17, but now I get this error when I tried to enable repo command. Says Flux is not ready yet. Could not create the port forward. Error upgrading connection. The only thing I can think of here is maybe you might want to check your Flux forward namespace environment variable. Upgrading connection. It says that the pod's not found, so that's a little bit strange. But then looking in here, this pod 6B7CB6588, that's a different pod name. It's very bizarre. Suppose this is why we call the feature experimental. Never run into these kinds of issues using this command before. But yeah, what I'm noticing here is that your Flux pod has a different name than the one that is listed in the error message. I'm really curious if you were to just run that again, what would be output, because this pod doesn't look to be inside of the Kubernetes API anymore. What I am also noticing is that your Flux has only been running for 40 seconds. So it might be crashing. It's my only guess. I'll keep that one on hand. Maybe we can look at it. Let me know if you are still having issues with the enable repo command, because you did mention that error about 6 minutes ago. And hopefully you can get it working. So at this point in the hands-on lab, once you have everything configured, then you can make sure that the profile's Helm releases are installed. So there is, this is dependent on the watch command here. You might need to install, what is it? Forget the package here on macOS, but it doesn't normally come with macOS, but you can just run the kubectl portion of this command if you don't have watch. And here in my particular cluster, we can see that these Helm releases are all deployed. So if the Helm releases are deployed, then what happens is there are CRDs that are installed. There's custom resource definitions for all of the additional infrastructure add-ons that we've applied to the cluster. Right? So we can see in the K8s AWS portion of the API versions, that there are virtual nodes and services for app mesh, as well as this meshes service. And then for Flagger, we can see there's metric templates as well as canaries. And then for Flux, we have Helm releases. And then we also have alert providers in Flagger. So then we can do, say, kubectl get mesh, right? And we can see that I have an app mesh that's been created. So there's the service mesh that's installing a service mesh through GitOps via a profile using EKS-Cuddle. And we know that the local repo's already configured. I'm going to skip the customize portion of this because I'll just be making some simple edits. But I've done this before many times. This is a solid way to modify the way that you're changing manifests to a patch-based workflow. I like customize for this kind of thing. It helps you factor the differences between your environments and some of the patches that we're going to be making to the, you can see here, this is configured with Flux YAML. So this is using the manifest generation feature that I had pointed out earlier. And then you then can check locally to make sure that your patches are applying properly. Then a little bit about the Canary custom resource. Ooh, my internet's kind of slow for a second here.
While we wait for you a second, just want to jump in. So I know that a lot of you are, or a group of you are not actually doing the hands-on, but it's cool to see that you're still watching. Do you have any just general questions about these steps or maybe choices we made in this hands-on? And I put in the chat as well that like in the future, we'd love to create other types of hands-on using different platforms. For this one, as we've talked about, we have EKS-Cuddle, so we chose EKS because it was a kind of an easy first version to do. But any questions from the broader audience that's just watching along, either on Zoom or YouTube? If you have any, please put it in the chat. And then, at least for me, Lee, your internet seems to be fine. I didn't notice any lag.
Yeah, I think I was just having an issue in Chrome or something, so seems good. And then, yeah, so we enabled the repo. We made sure that our platform was installed, including the service mesh and Flagger, and everything is managed by Git. So now that we have the platform, what are the things that we can do with it? So Flagger gives us the Canary custom resource. And what's very cool about Flagger is when you install it in whatever RBAC provisions that you give it, right? If it's confined to, a namespace and some cluster stuff, or just globally across the entire cluster, you can integrate it with a number of service meshes, load balancers, as well as just the Kubernetes default service mesh, right? The service routing that Kubernetes gives you out of the box using its canonical networking. So Flagger can integrate with Istio. It can integrate with Linker D2, right? Or Glue, Nginx. It can integrate with AppMesh. And so now that we have this managed service from AWS providing us an Envoy-powered service mesh that can do traffic shaping and that sort of bits, we can use the Canary custom resource as a generic interface to configure our specific infrastructure needs. And this means that if you're using, say, Istio on bare metal and AppMesh in AWS, you can have similar ways of managing your traffic using Flagger. Because the Canary resource is roughly agnostic to the service provider that is actually doing, it's actually implementing the policy. And so when I say policy, that's the way I like to think about a Canary. And so whether you are trying to do blue-green deployments, weighted traffic shifting, or A/B testing, you can describe those kinds of things inside of the Canary resource. And so what we do here is we target an existing deployment and horizontal Podo autoscaler ref, as well as a service inside of the Kubernetes cluster. And so we're using the default Kubernetes objects. We're not trying to extend our own canary deployment for that kind of thing. And so you get all of the benefits of what you've been doing before in Kubernetes. You can bolt Flagger on top of it using the canary resource. And then here in the analysis section, this is the meat of our declared policy of the way that we would like to do deployments and shift traffic with regard to when the deployment changes. Right, so we targeted our resources now from an auto-scaling deployment and service perspective. The horizontal pod autoscaler is kind of a requirement here for some very clever reasons. It's actually what allows us to use the default deployment object. It's not technically required though, but if you want good behavior, I would use this. And then the analysis section, we can say that over 10-second intervals, I would like to step the traffic weight from 5% on my canary starting out to 50%, right? So when I deploy, go ahead and do a canary release, make sure the infrastructure stood up. Once the deployment replica set is ready and those pods are capable of receiving traffic, start sending it 5% of traffic for 10 seconds, up to a max weight of 50% of my traffic, right? So that means that there are roughly 10 intervals here for 10 seconds. So we're talking about a 100-second policy that's described inside of the canary resource. If there are failures with Flagger during this time period, it'll gracefully come back up and continue what is occurring because it is a resiliently built Kubernetes controller, not just some bash script that's running in CI. And there's a threshold here, right? So basically, once we hit the threshold, gosh, I don't remember, I have to read the docs for that. I think that has to relate with the metrics. No, that the metrics have their own thresholds. So inside of the analysis section, in addition to describing how traffic should be progressed into the deployment, into my canary, I can also say that during this canary, ensure that my request success rate has a minimum of 99% availability over 1 minute query intervals. And that the request duration, right? So these are rate and duration, which are red metrics that are exposed by our service mesh. I don't have to instrument my application to do these things because at a protocol level, my service mesh understands and exports these stats about what is happening, right? So as traffic is then shifting to the canary, ensure that the canary is 99% available for latencies that are acceptable under half a second, basically, right? So the maximum that's allowed here for this 1 minute query is going to be half a second. And then in addition, we have this webhook section, which describes that during the canary deployment, I would like to actually run a load test against the canary to ensure that we have a synthetic amount of traffic, right? So, if you're doing a canary release at 9 p.m., that may or may not be peak load for you. And just to ensure that you're actually having some traffic to the application so that the metrics actually mean something, you can inject some synthetic load. You could also do things like run acceptance tests or different test suites here. You could try to batter your application with a bunch of bad data and see if your error handling is working. And this is testing in production, right? So when you see thought leaders on Twitter like Cindy Sertahan, talking about good patterns for testing and the gradient of testing, this is how you would do it. Canaries with these kinds of policies in place, as well as the ability to inject traffic during the rollout while you are shaping it, while you're watching the metrics. This is testing in prod, and you can do it using a declarative Kubernetes controller using the canary object, right? So let's try it out. What we've done here is a clever trick that you can do to kind of feature flag things from a declarative standpoint in Kubernetes. So Flux will actually look at all of the objects, and if you annotate your object to say ignore it, then Flux will not apply it, right? And what we've done with the demo namespace inside of the app mesh profile So you can deploy the app mesh profile and no apps are deployed, right? Say you want to do something else, do your own thing. It's completely useful to you because the demo namespace is not deployed by default. So this is a very simple place where we can annotate. Then this namespace should not exist. But if I say that Flux should not ignore this, then all of the resources that are deployed into the demo namespace, they don't have to be annotated. But now that that namespace exists, Flux will be able to actually apply them. This is a way to deploy the demo application right out of the box. So again, this is GitOps, right? So I make the change in the repo. I check my diff to make sure it's doing exactly what I want. I form a commit that says, enable our demo app, right? And then I just push it to the repo. Again, in a production setup, you could either wait the 5 minutes, on average it'd be 2.5 minutes, or you could increase your Flux polling loop. But I'm just going to also run a Flux-CTL sync.
Letting you know, there's also a question in the chat.
Oh, cool. Thanks for the heads up.
Craig has a few errors, which we'll have to copy paste again because people can't see.
Could not read from the remote repository. Yeah, okay, I see what's happening here. Craig, at the bottom of your EKS enable repo command, there is an instruction that is a little bit hard to see because the logger is in the same color, but it asks you to add the SSH key for Flux to the deploy keys settings inside of your GitHub repo. And if you don't have the logs anymore, what you can run is fluxctl identity. And it will print the identity of the public identity of the Flux D that's running inside of your cluster. So once you have this SSH key, right, because you have your own, right, but we don't put your SSH key inside of the cluster. That would be kind of mean. And so we generate a new one, right, an identity specific to your cluster, to Flux. And that key is what you then need to copy and then put into GitHub. So say it was my urban rotary phone settings. So you go to settings inside of your GitHub repo, and then you go to deploy keys, and you should see that there is a place to add a deploy key. And then you would paste the deploy key in here. You would give it a title. You would allow write access if you want. It's not technically required. And then, yeah, you should see the key pop up here. And then when the cluster syncs, it'll actually tell you that it was used inside of the GitHub repository settings. And then you can debug whether or not that's working using kubectl namespace flux logs deploy flux. And then you should be able to see that there's a message that will look like, to go up a little bit, it'll be component sync loop event refreshed on your GitHub repository. Once that occurs after you've at a timestamp that's after you've updated your key, then you'll know for sure that Flux is synced. Another way to debug it is to just try to run fluxctl sync manually. And we've fixed the majority of the bugs that occur in this kind of setup workflow. It used to be that Flux would kind of freeze, but I don't expect that you would have that issue anymore because we've worked out the majority of the bugs. If you want a fresh log or you're still doubtful that Flux is not acting buggy, then you can kill the Flux pod or delete it. And then the deployment will create a new Flux D pod and it'll start a fresh lifecycle with the new keys.
So that was quite a bit. I'll let you digest that a little bit. And I bet you have a question. It looks like EKS enable repo puts Flux in a namespace Flux, but Flux cuddle identity looks in the default namespace So I need to do flux cuddle identity dash dash
Yeah,
Kubernetes
that's
forward.
correct. Earlier, yes, the flag is the override for the namespace. Sorry, I should have mentioned this. If you want an easy way to not have to type that, you can export this environment variable, which is just an alternative to the flag. But yeah, that is totally correct what you're saying, to set the flux forward namespace.
Cool.
Yep.
Well, we'll wait for you to make sure that works out. Vincent, I guess you are following along a little. You said you're waiting for DNS propagation.
Nice. Yeah, that can take a moment.
Okay.
In fact, I will have to do that as well. My DNS may have propagated because I deployed I think I committed and I pushed, yeah, right? Thanks for joining and following along, Vincent. I hope that this workshop is very helpful for you.
I know you
Yeah.
stuck around even after Daniel's music was gone.
Yeah, I know. And the incentive, I mean, he just sets the bar so high. Now I have to follow up that. Yeah. We should have him play like elevator music or something like more boring, so I'm more interesting, right? So I'm just gonna look at the namespaces here. We can see that I've had a demo namespace for about 5 minutes. And then, yeah, we did have some instructions inside of the lab, inside of app bootstrap, where we patch the namespace to enable it, push it. And ooh, yeah, is the canary initialized? That's a good question. Yes. So we can see kubectl in the namespace demo get the canary. Right. So now we have a new resource that's provided by Flagger. We have a canary instance inside of our Git repo, and then that creates the pod info canary. So when Flagger says that something is initialized, it means that it's transformed the traffic routing from whatever was there before, just the deployment service and HPA, from being however it was initialized inside of Kubernetes and working, to transitioned and matching the policy in whatever service mesh Flagger is integrated with. So it would move all of that stuff over. And the Flagger logs are actually interesting as well. So if you were to say do kubectl logs, and I think we have, what's our namespace? It's called the app mesh system namespace. So get pods and app mesh system. We have an instance of Flagger running here. And then if we get the logs in the app mesh system namespace for the deployment called Flagger, then we can see the imperative logs that describe what Flagger was doing for us, right? So here we can see that it is actually referencing a deployment called podinfo demo, and that there's a horizontal and pod autoscaler and service that's associated with it. You can see the full algorithm that it uses to safely shift traffic away from it. And what do I mean by shift traffic away from it? Well, if we actually look at the deployments inside of the demo namespace, we actually have a primary and we have the normal one. So the normal one is actually what we declare in our repo. And then podinfo primary is actually a consequence or an artifact of the Flagger canary being applied to the podinfo deployment. So you can see here that the podinfo deployment's actually been scaled to 0. And so this is what I mean by initializing the deployment is Flagger actually copies this one into the primary instance. The primary instance is what will receive traffic, say, in a production setting, right? And so it copies it, including the desired replica scale, and then it scales this one down using the HPA. And then when a canary happens, right, this is your declaration. this is the one that Flagger owns, right? So when you change your declaration, it will deploy your version of the canary. Flagger will notice, but there's no traffic routing to it. Flagger can then check if the app is healthy and then decide to start shifting traffic to it progressively. Then if everything is healthy, by the time the canary is completed, then it will promote this to the copy, right? And you can read that in the logs. So hopefully, Vincent was mentioning he was waiting for DNS propagation, and so am I. But maybe everything is ready now and our app is actually deployed. Sure is.
Yeah, it looks like he said he's looking at the cuttlefish.
Yeah.
So yes, this is a cuttlefish clapping in anticipation. It's so excited
Uh-huh.
to see its traffic go to the
To the canary.
location. Yes, to the canary.
Yeah.
And then slowly over time, you'll be able to see the new cuttlefish. But yeah, Vincent was
This
saying
is
this
an
is cool.
example of the level of excitement that I would normally feel in a legacy environment doing deployments, right? Except probably more concerned and sweating at the same time. But
Just trying to make it to be like, oh boy, oh boy, oh boy, oh boy.
yeah.
Which is pretty much what I do. So that's how I drew it.
Yeah, we commissioned a very well-known artist out of Oakland, California, to put this cuttlefish together by the name of Tamo
Yes.
Nakahara.
So actually, I'm so you can see the couch background here, which Stacy did. So we also have actually she's a much more qualified artist. So I'm looking at gradation tools, so I can try to see if I can do a 3D version to sit on this couch. All right, I already have a version where I have a couple of gophers sitting on the couch, and I have to make them look a little bit more even in terms of their gradation, but just a little fun.
I'm enjoying some a matcha latte.
Yes,
right
I
now.
noticed you've been.
I'm kind of just like loaded with East
Yeah.
Asian beverages right now because I also have the Taiwanese boba.
Oh man.
Yeah. It's good. I don't go hungry here.
Is this actually routing traffic? I've noticed the cuttlefish hasn't changed.
Oh, well, it's because we just have the application up and deployed with the same version.
Oh, I see. Right.
So now would be a good time to start our canary deployment, which I imagine Vincent's gotten excited enough to go ahead and do, but it's just giving people some time. So if you look at, once your application is up, DNS is propagated, and you can print out the URL and go visit it, then you can start looking at going from an initialized canary to actually deploying something else, right? So here, if we just change the version of the application, then we'll go ahead and go into our Git repo. Again, I'm not going to mutate the Kubernetes cluster directly, right? That's not very GitOpsy, right? So we will go into the pod info application to the deployment. We'll change our image. And then we'll also change our, we'll change the container image, and then we'll also change the image that's being used, right? So if we open up this image, we can see this is what we expect is going to get deployed to our application. It's a much more satisfied version of the cuttlefish, right? So there's our version of local development testing. And then we can get the image pushed to CI and all of that as well. So I have the diff. I can I need to switch to double quotes if I want to use a single quote in my commit message. Okay, so we go ahead and push a commit. And then again, FluxCTL or Flux is always converging, right? But we can tell it to make sure that it's converged immediately about now. We have a bit in here about watching the logs as well. Where is it? Yep, it's right here. We're watching Flagger logs. So here I'm reading the Flagger logs just to check to see if it's doing what I've asked it to do, right? And what I've technically asked it to do is I've changed the declaration of the app, right? In the pod info version, which is the original version of my app, there's a deployment. I changed the declaration of the deployment inside of the Git repo. We have a canary policy that's already pointed at the deployment, right? And so now we see that Flagger is shifting traffic, which means that if I look inside, then right now it's about 15% of the time, and that will start to increase. We should see that we start getting responses from 3.1.1 version of our application that we declared the change to. And then the image should also start to change a little bit. So, and I guess we'll keep dragging it over to the side. So here there's 3.1, and now we have our image change, right? So there you go. That's an example of the benefits of progressive delivery as applied to Kubernetes. And my internet might be cutting out a little bit here because my Zoom is performing quite badly right now. Can you guys still hear me all right?
Yeah, at least it's working for me. And also, yeah, oh, now your voice broke down a little bit, but yeah, thanks to Craig who's given some pointers and said that maybe we can augment the section about keys, giving the exact URL. So thanks for that. Appreciate it.
Yeah, I could probably commit that.
Okay, cool.
That's good feedback. Yeah, I do think that we could improve the experience there a little bit by maybe adding some carriage returns into the EKS cuddle enable repo command output so that it doesn't just look like a big block of text, and then maybe highlighting it in like yellow or something instead of the blue logger.
Yeah.
Because I do think it's hard to notice that you're supposed to take that step. And so here we can see that a large percentage, right, of our requests are now routing to the canary. Well, let's just go ahead and check where we are supposed to be. So we got to the point actually where we reached a 50% weight of our traffic going to the canary. And in our policy, that is the point in which if we can reach that number of iterations, the canary is considered successful. So it's at that point, Flagger will actually copy the canary instance, which is our original version of the deployment, to the primary copy. Right? And then it'll roll that out, make sure that the rollout succeeds, and then consider the canary fully successful and deployed. Right? So here we can see that it is now promoted. And if we do kubectl in the demo namespace and we get the canary object, we can, not canary like the snail from SpongeBob, but canary, that isn't a bird that you send down a mine shaft. So here we can see that the canary has been succeeded with the recent transition time, right? So yeah, for me, it is 10:50, and we can see that this was at 49 minutes and 48 seconds. So, super exciting technology. And yeah, that is pretty much encompass the basics of Flagger. You can see now that our application after the canary has succeeded is now routing to 311 100% of the time. Probably close this out.
Reading a few more comments from Craig. Cool. Thank you. Thanks for taking time to write this out. We will definitely take it back. So we have just a few minutes till we close. We can wrap up here, or if anybody's like really, really close and you just want to see it through, it's great to see one person finished. Samit, I guess I want to check in with you. Let's double check that you're still here. You are. Seems like you were making progress. How close are you, and would you like any additional help? says yes. So yes, you're very close, or yes. Oh, doing the canary stuff. Excellent.
Nice.
Fantastic. So it sounds great. Yeah, let us know if you have any feedback as well. And excellent, excellent. And Craig, I know that you had some bumps along the way, and we really appreciate the feedback. I don't know, Lee, are these things that we can try to troubleshoot in the moment in just the minutes we have, or
Let me take a look. Let's see. So
just want to know where you are?
Vincent's trying to fail his canary now. Yeah, there is an example of how to do that by taking advantage of the load test infrastructure, Vincent. If you go ahead and you look at automated rollback, yeah, you're probably going right through this. That's why you mentioned it. Then you will go into the load tester pod with this kubectl exec, and then you can run your own failed load tests by invoking some particular routes that are part of the pod info application.
Cool. Well, I'm glad you guys joined, because we want to, like I said, I think you've already filled out our form. Please fill out the Google form, because this way, when things hopefully go back to normal or we can travel, we can say, we need to go to Paris because we have some t-shirts to deliver. We could do a GitOps event there.
Oh, interesting. I'll have to think about passphrase protected SSH keys and the auth sock, because yeah, that can be a tricky integration to get correct if you're, say, using Go's SSH libraries or something. I'll have to try that out. Thanks for mentioning that, Craig. Yeah, the SSH key setups are obviously something that can be quite variable. And Sumit mentions, have we tested this workshop using a custom VPC and IAM credentials? There's no reason why modifying the EKS cuddle config to use the VPC and IAM credentials would not work, but you do get into a more particular set of infrastructure knowledge that needs to occur there. It should work just fine. There are examples of EKS cuddle users doing that stuff. And then, yeah, if so, what AWS policies need to be applied to the user in AWS might be a good note. There's an example of the minimal tested IAM roles that have been provided by users inside of EKS cuddle GitHub issues. A little bit of searching inside of the issues on the EKS cuddle repo brings these things up, but let me see if I can find them. Great questions regarding how to basically slipstream EKS cuddle into your actual organizational policies and practices. So I think it's like something regarding IAM. Yeah, document minimum IAM requirements. This is the main EKS cuddle issue for this. And then if you scroll way down, there are examples of users that provide their EKS cuddle command or their particular EKS cuddle config, and then the roles that work for them. And the reason why this is going to be so variable is A, as EKS cuddle changes over time, it supports more and more features. And then B, not all users use those features, right? So for instance, I'm using AppMesh, right? So in order for me to be able to create a cluster that has access to those IAM roles, I need to have a superset of roles that includes that, right? I need to at least have the equivalent set. But a user who's not using AppMesh is not going to need the IAM roles necessary to do that. So that's just a particular difference. But this is EKS cuddle issue 204. And that should get you rolling as far as IAM roles and least privilege policies for that kind of thing. Vincent, you mentioned that would be interesting to you as well. Again, just check out EKS Cuddle GitHub issue 204. And
Excellent.
I'm glad that you're able to make your canary fail. That's funny. This is the only time you've been excited for a deployment to fail. Yeah, it's really cool when you inject the failure in and see how it behaves, because it's handling failure in a way that's just so much cooler than the majority of things that could do this kind of traffic shifting. It'd be very difficult to write a bash script that behaves as well as Flagger does. So very excited to have been able to share this time with you, share this technology. We're building a huge community around Flagger, lots of production users already who are using it in even multi-cluster environments and that kind of thing to do traffic shifting with mature, descriptive, declarative, GitOps-driven policies. I get super excited about this technology. I think it's like one of the coolest things that we've ever built at Weave. Very forward-thinking, and hopefully, if you don't choose to use it, it's at least helped you understand good patterns for why GitOps is such a big deal. Now that we're building these higher order integrations on top of the open implementation of Kubernetes, we have a way to describe the way that systems should interoperate on a way that at a level that's unprecedented, right? We couldn't do this kind of stuff in the industry using open technologies before. And because of that, you hit this really limiting factor, which is that people just don't know enough and aren't good enough to build the entire universe from scratch, right? But now that we've got all of these open systems and standards, we have interfaces by which these systems can communicate. We've got accepted models and ways to run resilient controllers that are built on consistent storage so that they can implement correct state machines that are going to be able to handle failure modes that are common. It's a really exciting world for platform builders and for people who want to provide an incredible development experience and ultimately accelerate the way that your business delivers change and monitors failure. When you look at the statistics from the DevOps Research Association, the people who are deploying more are deploying much more frequently with low mean time to recovery and low failure rates. Those people are leading the industry. And so doing software well, and beyond that, the encompassing part of doing your infrastructure well, right? Operating it continuously and with mature patterns using GitOps, I think it's a massive leap forward in a maturity model approach to, doing business. It's a good thing. Makes me excited.
Yes, and thank you so much, Lee. Thanks for walking us through this very long hands-on, the talks and the hands-on troubleshooting. Thanks to all of you for joining our second practice run as we lead up to GitOps Days. If you have any feedback on the hands-on itself, and Craig will take a lot of the feedback that you had, Zoom versus YouTube, as well as whether you find this format useful. Like this is the first time we've done the actual hands-on on live where we walk people through it. So it's good to see